In this lesson, we are going to end up with some applications of right triangles, and we're going to be doing this example here about a handicap ramp. And to work this out, we will be using one of our trig functions from the last lesson, sine, cosine, or tangent. Now, before we get to that, let's just do some practice on some right triangle problems. And what we'll do is we're going to use our trig functions to find some missing measures. And then we will apply it to our problem with our handicap ramp. So let's say we're trying to find A, and that's the side of this right triangle here. And we're given some information. This is a right angle. Whoever drew that. This is 42 degrees, this is 20 inches, and I want to know this side here. Okay, we're going to use one of our trig functions. Remember, we had sine, cosine, and tan, and sine was opposite over hypotenuse. Cosine was adjacent over hypotenuse, and tan was opposite over adjacent. So our sine of an angle is opposite over hypotenuse, cosine adjacent over hypotenuse, and tan is opposite over adjacent. We're going to have to pick the trig function that will help us out here. Well, let's see what we know. We know this side is 20 inches. So, well, that's a hypotenuse. That is the hypotenuse. So we want to use one of these ratios. Now, let's see what else we know. We know the angle is 42 degrees and the side touching it is A, and that's what we want to know. We don't know anything about this side. It's not marked with a number or a variable. So we're looking at the adjacent side of 42 degrees and the hypotenuse. So we want to use cosine. The cosine of 42 degrees is equal to its adjacent side over the hypotenuse, and now we've made a simple equation. Well, if you recall, when we solved equations in an earlier lesson, we want to get rid of this 20 here. We're going to multiply by 20 on both sides. And that will cancel here. And so 20 times the cosine of 42 degrees will equal to our missing measure of A. I'm going to put this in first. The order of multiplication doesn't matter. Remember, in this calculator, we put the angle in first, then hit the trig function, then times 20, and I get this here, and I'll just go ahead and round that to 15, to a whole number. So side A is 15 inches. Let's try another one here. Sometimes it may not be written in the same direction. This one's, I guess you'd say, upside down. My right angle's here. You can always flip your paper around if that makes you happy. And let's say that I'm trying to find this side here. I'm given this side, and I don't have any units for this one here. And let's say that I know that this angle here is 67.7 degrees. And I'm trying to find this side. This side is my hypotenuse. I'm given this side, which is opposite of that angle. So let's go up here. Left off my E there. Let's go up here and find the one that has opposite and hypotenuse. That would be sine. The sine of 67.7 degrees is equal to the opposite side over the hypotenuse, which is little c. Again, we did not use this side because it wasn't marked with a number or variable. Now, how do we do the algebra here? Well, I don't like that c being down there, so I'm going to multiply both sides by c. So I can get that out from under the fraction. So now I have c times the sine of 67.7 degrees is equal to 18.8. I'm solving for c, so I can divide both sides by that quantity, sine 67.7. And by law, I need to do it over here. So when you have this situation here, you're going to end up with c equals to 18.8 divided by the sine of 67.7 degrees. Okay, let's put that in the calculator. So I have 18.8 divided by 67.7, hit my sine key, hit enter, and it looks like side C is about 20.3, and the units would be whatever units if they were given there. So if this side is 18.8, we found the hypotenuse, and this is that angle. This is the length of the hypotenuse. Okay, let's try another one here. And this is number 3. We're going to find side A. They typically use A, B, and C. You can use other letters. It's like you can use any letter for an angle. This may not be to scale, but let's say this is 85.73 kilometers. And I know that this angle here is 43.58 degrees, and I'm trying to find this distance here, okay? This is something surveyors use also to find distances. Okay, let's see what we've got here. I've got the side, I'm looking for the side opposite of the angle. I do not know the hypotenuse, so let's go back and look at our little sheet here. I don't have the hypotenuse, so neither one of these is going to help. How about tan? Opposite over adjacent. Let's use that. So the tan of 43.58 degrees is equal to the opposite side over the adjacent, and this is the adjacent. It is touching the angle. And we will solve that by multiplying both sides by 85.73. And so I'm going to find the tan of my angle, and then I'm going to multiply it by 85.73. I put my angle in first for this calculator, hit tan, times 85.73, and it looks like my missing measure is 81.58, and I'm going to put that in kilometers because I was given a unit here and I'm finding a missing side. If I'm finding a missing angle, it would be in degrees. Here's one where we're going to find an angle. So let's say we're given two sides of a right triangle. And let's say this is 1,358 feet. I've got my feet marked there. And this is 2,540 feet. And I want to find angle B. Let me write that down. So I'm finding angle B. Okay. First off, we need to pick the correct trig ratio. Well, We are not given the hypotenuse. Remember, the side opposite the right angle is a hypotenuse. It is not labeled with a number or variable, so we must be using tan. So the tangent of angle B, tan is abbreviation, the full word's tangent, remember is opposite over adjacent. Again, you're going to want to keep these handy right here. And my opposite side is that side there. And this side is adjacent to B. Now, remember for this one, when you're finding the angle, we put this number in first. We go ahead and calculate that ratio, 2540 divided by 1358. That's equivalent to that decimal. If I'm going back and trying to find the angle, I hit my blue key and hit tan, and I get 61.87 degrees. Let me just write that down, and then we'll change it to degrees in minutes. So this is what I have right now. So B is 61.87 degrees. Now remember, if they want in whole degrees in minutes, it's 61 whole degrees. We want to change this part to minutes. Let's take off the 61. There's my decimal that wasn't rounded there, and times 60. It would be 52 whole minutes. Okay, so in this fifth example, let's draw it and see if maybe you can figure out how to set it up. Let's write it down, and I encourage you to pause and try it yourself. So I've got my right triangle. And that's 8.57 meters. I'm looking for A, that's the label there. I'm given that the angle is 28 degrees and 20 minutes. Okay, why don't you stop it now and see if you can find the trig ratio to use. Okay. We're given the hypotenuse in meters, so we know the hypotenuse, so we definitely want to use one of the ratios that has hypotenuse in it. I can't spell right now. Oops. Okay. And as far as side A, this A is opposite of this angle, not adjacent, so we are opposite. So we're going to use the trig ratio that has the O and the H in it. And we look at that first page, and O and H is sine. The sine of 28 degrees and 20 minutes, I'm going to do that like that so you know that's all that angle, is equal to the opposite over the hypotenuse. We'll solve for A first, and we'll be multiplying by 8.57. And this will cancel. So to get A, I'll be plugging that in the calculator. We're going to do this first. And remember what we do when we have degrees and minutes. We need to put parentheses 28 degrees plus 20 divided by 60, because there's 60 minutes in a degree. That's the decimal. Then we hit our sign. Now we'll multiply by 8.57, and A is 4.07 meters. The units are meters because we're talking about a length, and that's what the hypotenuse was given in. Okay, let's go through one more, and then we'll look at our handicap ramp. Let's say we want to find all the missing parts of this right triangle. And we're given, let's just call this A, B, C for our angles. And let's say that little a is 36 feet. we've got to be given at least two pieces of information. And let's say that angle B is 61 degrees. So we're given that. We've got to be given some information. Okay, the easiest thing to find first is angle A. Angle A, remember, would be, these must add up to 90 degrees because 90 and 90 is 180. So 90 minus 61 is 29 degrees. Let's see, we can find little b. Let's call this little b and this little c here. That's usually how they're marked in Trig, is if this is angle B, they put little b across, C across. So anyway, these will be labeled for you. And let's say I want to find little b here. I'm trying to find this here. Now I'm going to use this angle just in case I made a mistake here, which we know this is right. If I'm going to use this angle to get some information, this angle is opposite of this and it's adjacent to that. Opposite and adjacent. That's our tan. So to find side B, to include that, we don't know C right now, and let's say we haven't found A yet. The only two pieces of information we have are these two, so we want to use tan because that is the opposite over adjacent. So the tan of 61 degrees would be the opposite side, which we've labeled little b, over the adjacent side, which is 36, and we'll solve that by multiplying both sides by 36. I'm going to find the tan of 61 first. 61 tan times 36, and that let's see, 61 tan times 36, 64.9. I'll just round that to 65 feet since everything else is in whole numbers, okay? So now we know every angle. That's a right angle, that's 61, that's 29. We know this side and this side. Now to get C, you have a couple of choices. You can use one of your trig functions, which I'll do, but you could also use the Pythagorean theorem. A squared plus B squared equals to C squared. Okay, well, let's say I want to use my trig ratios, and again, let's use what we originally had to begin with. So if I want to find side C here, okay, my hypotenuse, I want to use one of my trig functions that has hypotenuse in it, and so that's going to be cosine or sine, and I know the adjacent side to be, so adjacent and hypotenuse would be cosine. The cosine of an angle is the adjacent over the hypotenuse. So the cosine of 61 degrees is 36 over C. We'll work that out like we did the one in the previous page. If you want to go back and look at that, we ended up with C equals to 36 over cosine of 61 degrees. You can just look at that previous example. It would be worked out like we did number 2. I'm just taking a little shortcut here because I'm running out of room. I want to do 36 divided by 61. I put that in, hit cosine, and then hit enter, and that's about 74 feet. Okay, let's finish up with the handicapped ramp. Like I said, there's a lot of applications of right triangles. And we're building a ramp so that we can have access to the building. And these ramps usually have a low angle of elevation, obviously. You don't want it too steep. And that's 5 degrees right there. This has to be 8. We have to make it long enough to where this is only 8 feet up. Maybe it's got to go up to a door. We want to know how long the ramp must be. You can use any variable, but I'm just going to put C because that's what we've been using. Now for this angle, I have the opposite and the hypotenuse. Okay, so I have opposite and hypotenuse. If I go back here, that looks like we want to use sine. The sine of 5 degrees is equal to the opposite, that's going to be 8 feet, over the hypotenuse. Let's go back through the algebra here. This takes 2 steps. We've got to multiply by C to get that out of that situation. So we have C times the sine of 5 degrees equals to 8. And to get C by itself, we'll divide by the sine of 5 degrees. So let's see what we get. C is equal to 8 divided by 5 sine equals, it's going to be about 92 feet long. Okay, so it's going to take up a lot of room. That's why a lot of times when you see a handicap ramp, it might have switchbacks back and forth so that you get enough distance here so that the angle isn't too high.